construct equilibrium curve. So this is our equilibrium curve. Y naught is equal to f of x. Then, the horizontal line is your y is equal to minus 1. This is the inlet gas composition and is the physical location of the outlet vapor compositions. And this horizontal line is your x is equal to x sub 2. This is where you found the inlet solvent vapor composition and is the physical location of the outlet gas compositions. This area bounded by these three lines are your physical region. So the operating lines are found in this region. So if we were to construct this line, operating line, with a slope now L sub f over G sub f. This is the minimum operating line is when this point intersects with the equilibrium curve and the bounds. And then to know if particular design is feasible, it must fall within this envelope. Kasi once we lower down the slope, or mag-horizontal. So, pag ito. Pag naman increase, mag-vertical siya. If ang tendency niya, mag-vertical, so mag-wall siya, pwedeng gumanyan. Pag ganito na, so ibig sabihin, yung proposed design mo, hindi na siya suitable. So, yun. Tapos with these diagrams, the possibility of making mistakes could be minimized. And so the designer should evaluate without difficulty the effects of any variable changes.
So, in industrial scale gas absorption towers, there are two main types of designs, and the first type is the packed tower design. In our past chemical engineering subjects, we have been familiarized with distillation columns and other such towers that use plates as the site for mass transfer. In contrast, a packed tower is a vertical column filled with inert materials or tower packings until the brim. So kung iisipin nyo, para lang siyang Coke baso na ginanon ng ice, parang Coke float. Packed lang talaga siya. Next slide please. One of the main factors that contributes to the general capability of packed tower design is the backing material. Anyway, wala pa siya. The primary purpose of backing material is to increase the surface area for a better mass transfer rate. Backing material generally can be made of plastic, metal, or ceramic. According to Paris Chemical Engineer's Handbook, there are three classes of backing materials. First of which is the random or dump packings. Random or dump packings have a specific geometry and are randomly packed inside the column shell. For the characteristics of these types of packings, see Paris 7th edition, table 14-7b, or for the 8th edition, 14-13. So from left to right, yung pictures kanina, yun ay Rashid rings, Powell rings, and Burl saddle. So imagine nyo lang, itong mga packings na to, isiksik nyo lang sa loob ng parang cylinder, yun yung packing tower. Next slide. The second class is the structured or systematically arranged packing. These are crimped layers of corrugated sheets or wire mesh that are stacked in the column. So, isipin nyo lang parang mga bilog-bilog na pinagpatong-patong. So, para siyang fan shape na ginawang pabilog. Tapos, stack nyo lang siya ng vertically. Yan na siya. Yung characteristics naman nun ay nasa 14-7A or 14-14 kung 8th edition. The third type of packing material is the grids, which are simply systematically arranged packings with an open lattice structure. And so, Ulitin ko lang, yung tatlong types natin ng packing material ay random, structured, and grids. Now, we should take into account some considerations when choosing our packing material. The first is the cost. Plastic packing materials are generally the cheapest, while the ceramic packing materials are the most expensive. We should also minimize pressure drop because as pressure drop decreases, size increases. And then we should also consider the atmosphere inside the pack tower. And if we are dealing with a corrosive atmosphere, we should use ceramic packings to avoid corrosion. And then we should also consider the structural strength of our packings. Our packings should be able to withstand different kinds of loads and thermal stress so that the lifespan of our pack tower will be longer. It is noteworthy that ceramic easily cracks due to changes in temperature. And then we should also consider the weight of our packing materials because if we use a heavy packing material, we will need to add more supports or use a heavier tower construction, which will mean incurring additional costs. When choosing the lightest, we should select the plastic type of packing material. And then lastly, we should consider the design flexibility of the packing material. And this means that our packing material should adapt with the changes of the process. I mean, even if process changes are present, the efficiency of the pack tower should relatively stay the same. Okay, so, Paris Chemical Engineers Handbook has outlined some packing objectives that we must consider in order to maximize the efficiency of our pack tower at a given capacity at a given flow rate. Okay, so Perry outlined 5 guidelines for us to follow. And the first is to increase vapor-liquid contact area by decreasing random packing size and increasing efficiency, which increases efficiency. Okay, and then similar to that, we can also improve vapor-liquid contact by spreading the surface area uniformly, which will also increase the efficiency. And then we should also maximize the void space per unit volume because this will minimize the resistance to gas upflow and increase capacity. However, kung mapapansin ninyo, dun sa kaninang guidelines, yung unang guideline ay para sa pag-increase ng efficiency at yung pangalawa. Pero itong pangatlo, siya naman ay para sa pag-increase ng capacity. Kung naalala nyo dun sa past topics natin, kunwari sa screening, yung capacity at efficiency natin ay opposing factors. So, sa pag-design natin ng tower, dapat makuha natin yung sakto at optimal na combination ng efficiency at capacity. Okay, so next. The fourth guideline is to minimize friction by choosing packing with good aerodynamic characteristics. And lastly, we should minimize cost by, for random packings, increasing the packing size, or for structured packings, increasing the space between